Last chapter we talked about solving rational functions. Today, we're going to graph rational functions. So we've seen them, we just really haven't graphed them. And you probably did a little bit of this in Algebra 2, but we're going to look at lots of different ones. And I would say probably the biggest thing that's different about rational functions as opposed to like quadratics or cubics or things like that is all your graphs look different. We know that when we have a quadratic, it's a parabola. We know that when we have a cubic, it's kind of the snake-like graph. When we have a rational function, all these rational functions have a little bit different shape because of some different things that are going on with each one. So we're going to talk about some of the things that make up these rational functions first, and then we'll do a couple of examples that put it all together. Okay, so first up, a rational function is when we have a polynomial divided by another polynomial. And we've kind of been doing that throughout the chapter where we've done long division, synthetic division, and things like that. So we have a polynomial divided by another polynomial. So we call that a rational function. And we are going to be kind of looking for the zeros today, but we're going to look for some other key components of that as well. There are three things that we look for when doing a rational function. Okay, the first one is what we call the vertical asymptote. And we're going to be doing this a lot today. And so from here on out, I'm just going to write VA instead of vertical asymptote every time. And obviously I'm okay if you do that too. I'd probably encourage you to do that because you probably don't want to write out vertical asymptote every time you do it. So we're going to do vertical asymptote. Now the vertical asymptote, to find it, what we're always going to do is set the denominator equal to 0.
The colors of the sky fade with the setting sun.
Okay, thanks for that input. Okay, another one is a hole. Okay, a hole goes right along with a vertical asymptote, so these kind of go hand in hand a little bit. But if you have a common factor on top and bottom, then we'll take that common factor and set it equal to 0. So I might have like an x plus 2 on top and an x plus 2 on bottom. I would set x plus 2 equal to 0, and that would end up giving me a hole. We'll talk about what all of these things look like when we start graphing and talk about what a hole would look like. Some of these things we have to find by hand because the graphing calculator is not great graphically, and it's not going to be able to express or put a hole in your graph. So there will be an actual hole in the graph, but your calculator won't show that to you. Okay, and then finally, the third one, or the third thing that we're going to talk about is horizontal asymptotes. And from here on, I'm just going to use HA for horizontal asymptotes. Horizontal asymptotes are always based on the degree. Okay, and we're going to talk about the degree of the top versus the bottom and compare them. And there's three things that could happen here. We could say the top degree is bigger than the bottom degree because both your top and bottom are going to be polynomials, right? So you're going to have a degree on top, you're going to have a degree on bottom, and we're going to compare those two. If the top's bigger than the bottom, if the top is less than the bottom, or is the top equal to the bottom? Three different scenarios that could happen. Okay, if the top is bigger than the bottom, then there will not be a horizontal asymptote. So we would say there's no horizontal asymptote. If the top is less than the bottom, the horizontal asymptote is y equals 0, otherwise known as the x-axis. So your x-axis would be the horizontal asymptote. It's going to be going across like this. This is the equation for it, but we know it as the x-axis. Okay. I haven't really talked about this today because you guys have seen asymptotes before, but it's been a while. An asymptote, remember, is a line that, like, if I have a vertical asymptote, the graph's going to get really close to it, but it will not touch it. Okay, it will not cross it. Same thing for a horizontal asymptote. It's going to come down and it's going to get really close to it, but horizontal asymptotes are a little bit different. There are times where a graph might cross a horizontal asymptote. I'll show you a situation like that today, but a vertical asymptote, it will never cross. Okay, so it's going to get really, really close to it and hug right up against it, but it will never cross it. If the top is equal to the bottom, then we're going to divide the leading coefficients. So I'll give you an example here. In this case, my degree is 2 on top and 2 on bottom. So top and bottom have the same degree, they're equal to each other. And because they have the same degree, we're going to divide the leading coefficients. And I call this my A value and this my B value, so we would say y equals A over B. And that would be your horizontal asymptote. So that's kind of the weird one. Doesn't happen a ton, but we will see that from time to time. And if that's the case, then we divide those leading coefficients. All right, so those are the three things that we're going to do today. Before we graph, we got to decide where's our asymptotes going to be. Do we have a hole or not? Sometimes we won't have a hole. A lot of times we won't have a hole. And then we're going to use our calculator to help us graph. Okay, so you will need your calculator out today if you don't already have it out. Let's get it out. Just be able to look at what we said here. If the top is bigger than the bottom or if the top is less than the bottom. In this case, the top is less than the bottom, so my horizontal asymptote is y equals 0. I'd say that's the one that's the hardest of all of them, y equals 0. My x-axis is my asymptote. You need to kind of practice putting these in to your calculator. All right, let's start with a fairly easy one. One over x minus 3. 1 over x minus 3. And I told you that it's going to be a polynomial divided by a polynomial. We don't typically think of this as being a polynomial, right? Because it's just a number. But this is still a polynomial. It's a constant, right? A constant is a type of polynomial, but we don't always consider it to be a polynomial. We think we have to have x's in it to be a polynomial, but not necessarily, because it's a constant. And so it's still a number, it's still a polynomial. So I'm going to make it look like this. I'm going to say vertical asymptote, whole horizontal asymptote. And then one other thing that we're going to find is what is my x-intercept, what is my y-intercept. X-intercept is something that we've talked a lot about throughout this chapter already, so that's going to be something that we're going to focus on. Y-intercept just gives me an additional point to help us graph it and kind of guide where my graph's going to be. All right, so vertical asymptote. I probably would start with holes here. There is no common factors on top and bottom, right? If I had an x minus 3 on bottom and I had an x minus 3 on top, that would be a hole. But there is no holes here, so I would say none for holes. Okay, my vertical asymptote would be at x equals 3. Set x minus 3 equal to 0, set the denominator equal to 0, solve it for x. My horizontal asymptote, what's the degree of the top here? If there's no variable, my degree would be 0, okay? No variable means no degree, and here my degree would be 1, okay? So the top is less than the bottom, right? My degree on bottom is bigger than the degree on top, so if we go I'm going to make a graph here. When I draw these asymptotes in, I'm just going to do it as a dashed line. It's not really part of my graph. And you won't see these dashed lines most of the time in your calculator unless you have like a really old calculator. It kind of looks like an asymptote. It's just bad graphics is what it is. Newer calculators especially don't draw the asymptotes in there. We're going to put them in there so we know that's a line that the graph is approaching. And same thing coming from the other way. We just said y equals 0 or the x-axis is my horizontal asymptote. Those are the two lines that this graph is going to approach. Okay, for the x-intercept, we set the numerator equal to 0. Okay, but there is no numerator, right? It's just 1. I can't set 1 equal to 0. So in this case, we would say there is no x-intercept. There's nothing we can set equal to 0. For the y-intercept, we could plug 0 in for x and find out what y is. Okay, it wouldn't be difficult in this case, but most of the time we probably could just look at our calculator and get it off our calculator. But in this case here, 0 minus 3 is negative 3. And then this would become 1 over negative 3. And that would be my y-intercept. Okay. And so that would be like right here, just below the x-axis. Okay. And then we're going to use our calculator to help us kind of sketch a graph. My graphs don't have to be real particular here or perfect. I'm not asking you to come up with a big or a bunch of table of values here. We're just going to use all this information to kind of help us guide what we got. Okay, so let's put this into our calculator. It's going to get really close to those asymptotes, but not cross it. And that's our graph. Okay. If you really want to get more specific, you could graph some points and things like that, and there's going to be points on here. One thing that I would show you as well, these are again. Bless you. Okay, this one is a little bit more involved. We got a polynomial on top, we got a polynomial on bottom. And even before I graph it, I would encourage you to find the asymptotes. You will have some questions on the test next week where it'll just say, what is the vertical asymptote? What is the horizontal asymptote? Are there any holes? Things like that. So you may not have to graph it in every case. So you are going to need to be able to find each one of those things individually. There will be questions asking for those particular things. I think on the assignment today, you'll have that as well. So just so you have some practice doing all of that stuff. So once again, vertical asymptote, holes, horizontal asymptote. Those are the three things we're always going to start with. Okay, this one's a little bit more difficult because it's not in factored form, right? There's going to be a lot of good stuff if we have it in factored form. Sometimes it may already be in factored form. This one is not. We want to factor it if we can factor it, okay? So that means you might do dots sometimes. You might do slide and divide. You might do product and sum. Probably not any grouping today, but I guess there could be grouping. But most of the time it'll be one of those three methods: dots, product and sum, or slide and divide. So how are we going to factor the top? What does x squared minus 1 factor into?
X squared plus 1, I mean, X squared, X minus 1.
X plus 1, x minus 1. Okay, and then the bottom is a trinomial, okay? And we don't have a leading coefficient, so we're going to do product and sum here. So we're going to say what multiplies to get negative 6 and adds to get 1. Okay, 3, negative 2. And it doesn't matter which one comes first, which one comes second. Okay. I know that I list wholes second, and it really doesn't matter where I list it, but I usually look at wholes first. Do I have any common factors on top and bottom? No. If I had a common factor, that would be a whole. There is none. I'll show you an example here in just a second that will have a whole. This one does not have a whole. Okay, vertical asymptotes. We're going to set whatever denominator we have that's not a whole equal to 0. Because we're in college algebra, hopefully we don't need to write it out and then add or subtract one step. So x equals negative 3, x equals 2 would be my two vertical asymptotes, right? It's just one-step equations. In some cases, it may be a two-step equation, but pretty straightforward. Okay, horizontal asymptote, I would probably go back and look at your original equation, the way it's written, because that's the easiest one to determine what my degree is. In this case, the degree on top and bottom are both 2, so the degrees on top and bottom are the same. So if they're the same, we're going to divide our leading coefficients, which are both 1. So this would be y equals 1 over 1, which is really just y equals 1. Okay, we're going to put our asymptotes up here. This one's a little bit different because it has 2 vertical asymptotes, negative 3 and positive 2. It has a horizontal asymptote of 1. So those are the lines that this graph's going to approach, okay? And I told you that all these graphs are going to look a little bit different. There's not just like, this is the one they all look like. And each one's going to have a little bit different look, mainly because of all these different asymptotes that we have, okay? Now, if I were to find x-intercepts and y-intercepts. For the x-intercept, we're going to set the numerator equal to 0. So if I set x plus 1 and x minus 1 both equal to 0, my x-intercept would be at a positive 1 and a negative 1, so I'm just going to write it as positive and negative 1. I'm going to go ahead and put that on my graph. Those are the two places it's going to touch the x-axis. I'm just kind of adding all this information as we go. Okay, my y-intercept. If I put 0 in for x, you got a couple of options here. You can plug it into the factored form, you can plug it into the normal form or the standard form. I would probably do this because I think it's a little bit easier. If I plug 0 in here, this would be 0 squared minus 1, which is negative 1. This would be 0 plus 0 minus 6, which would be negative 6. So really, your y-intercept is just negative 1 divided by negative 6. Because when I plug in 0, I get 0, right? And negative and a negative would make that a positive. So my y-intercept is going to be at 1/6, which is kind of weird, right? It's a fraction or a decimal. And so it's going to be just barely above the x-axis. Okay, so those are kind of the key things that we're looking for. Because we have no idea what this graph, I'm not going to expect you to know what all these graphs are going to look like. Frankly, I mean, I can look at a polynomial still, and I don't have any idea what some of these are going to look like just because of all the intercepts and asymptotes and everything. So you're going to have to use your calculator to come up with a picture of what this graph's going to look like. Okay, once we have all of this information, that would be our graph. Okay, it puts all that information that we just found out together and kind of uses it to help us with our graph. Okay, if you go right to your calculator on this and you don't do all those asymptotes, then it's going to be a struggle, right? Where are those asymptotes? Where are these lines that it's approaching? So trying to do it without finding them first, I think, makes it a little bit more difficult. So if you find those three key things first, then it helps you with your graph a lot more. Okay, questions on that one? Okay, let's look at a third one here. About it. If it's not already factored, I would factor it. The bottom is already factored. The top is not factored. So we're going to factor it. It's another DOPS. So if we write it completely in factored form, it would look something like that. Okay, so on this one, we're going to see something we haven't seen yet. We're going to see a whole. Because I see a common factor on top and bottom, x minus 2 is a common factor, we're going to set x minus 2 equal to 0, which would be x equals 2. Okay, the whole can't be put on our graph until the very end. And I'm going to show you here when we graph it that the whole does not show up in our graph. Okay, so that is something you're going to have to be able to determine on your own and be able to put that whole in, and I'll show you how we put that in when we graph it. Okay, vertical asymptote is anything that's not a whole that's on bottom. So the x minus 2 is already used, right? It was a whole. So it can't be a whole and a vertical asymptote. So the only two things left on bottom would be these two factors. So we're going to set x equal to 0. And x plus 5 equals 0 would be x equals negative 5. So we have two vertical asymptotes and a whole in this case. Those two kind of go hand in hand because either it's a whole or a vertical asymptote, one or the other. Most of the time it's a vertical asymptote, unless it's a common factor. Okay, and this one here, this one's maybe a little bit harder to come up with my horizontal asymptote because we know the degree of the top is 2. What would be the degree of the bottom? If I were to multiply all those things together, it'd be 3, right? And here would be the easy way to do it. X, x, and x. If I multiply 3 x's together, that would be x cubed. So the degree of the bottom is 3. The degree of the top is 2. So the top is less than the bottom. And when we talk okay, x equals 0 is a vertical asymptote. X equals 0 is your y-axis. You probably don't have to put a line right on top of it, but I'm going to here in a different color just so you know that that's an asymptote. That's an asymptote. And then so is the x-axis. So kind of like the last one where we have two vertical asymptotes and a horizontal asymptote, just in different places. Okay, we can't put the hole in until we graph it, so we're going to wait until the very end to put our hole in. Okay, x-intercept and y-intercept. I'm just going to find those on the graph here, and I'm going to talk about that a little bit because it's a little bit different than the first couple that we've done. Mainly because we had a hole, and also because of the way the form is written here. Okay, so let's go ahead and put this into our calculator. Now, when we put this into the calculator, you have all kinds of options here. You could put it in the factored form. You could put it in like this. I mean, if you really wanted to, you could multiply all this together, but I don't really want to multiply it all together, right? So if you don't multiply it all out, like the bottom especially, then I want to put parentheses around the whole thing. So where you put parentheses is going to be a big deal here. So here's how I would put it in. Okay, so it's going to go through at -2, and it's going to kind of curve down here. It's going to approach both of those axes, or asymptotes, I should say. Okay, and then at x equals 2, we said there is a hole. So when we draw this last part in, we're going to put a hole in the graph at that point, and then it's going to continue on. So that's exactly what it is. It's a hole. There's a hole in the graph at that point, at x equals 2. Okay. Questions on that one? Kind of different, right? Because of the hole, especially. All right. I'm not going to go through this whole thing, but I want to show you this scenario because this is kind of a weird thing that happens. This is kind of similar to the one we just did. Okay, I'm going to go ahead and factor the top. Okay, would there be any holes in this one?
Yeah.
Where would it be? At 0, yep. Because we got a common factor of x, right? Common factor of x would be a hole. So x equals 0 would be my hole. My vertical asymptote would be at +1 and -1. My horizontal asymptote, the degree of the top is 2, the degree of the bottom is x times x times x, which is x cubed. So 2 is less than 3, so it would be y equals 0 once again. Top is less than the bottom. Okay, my x-intercepts here, and this is really the big one I wanted to show you here. My x-intercepts, this is not an x-intercept. We're going to set the numerator equal to 0, but this was a hole, so it's not an x-intercept, right? But this one would be, okay? X minus 4 equals 0, which means x equals 4. Okay, I'm going to go ahead and put this one in the calculator before, and just so you can kind of see the graph. Okay, lots of stuff here. Each one is a little bit different. I can't stress enough that, the homework problems that I give you, I try not to overdo it with homework, but if you do these things and you're doing your assignment, then you're going to see all these different scenarios. You're going to get practice putting it into your calculator, finding your asymptotes, doing all those things. So it is really important that you're going through and doing those and understanding it. Don't just look at Mr. Ruta's work and say, yep, I see what Mr. Ruta did here, right? Make sure you understand how to do it, how to put it in, and those kind of things. Okay, I think there is one, number 30, I think it is. Let me look here real quick. Yeah, number 30. We'll do that together on Tuesday. So you don't need to do that one this weekend. It talks about an oblique asymptote. We didn't have time to get to an oblique asymptote today. So you can skip over number 30.
You're not doing our math.